Hey everyone, this is question 19 for chapter 12, and it reads, one end of a uniform 4-meter long rod of weight Fg is supported by a cable. The other end rests against the wall where it's held by friction. The coefficient of static friction between wall and rod is the mu 0.5. Determine minimum distance from point A at which additional object, also with the same weight Fg, can be hung without causing the rod to slip at point A. So this is the basic diagram given in the question. And what you know is that this beam thing has a weight of Fg. So it would look like this. And this additional object would also have a weight of Fg. So it would look like this. Now, in addition, the string would have tension, points this way. And there is normal force applied here. And of course there is friction on the wall, and if there was no wall, this beam would be falling down, so with the wall, friction would be going upwards. And friction is always mu times normal. So that's the basic diagram which we start. We're going to start with sum of forces in the x direction, which will all equal 0. And it includes the normal force here. And then plus this x component, which is actually going in the negative direction. So it'd be negative t cosine 37. And this would, of course, equal 0. So n would equal t cosine 37. And if you want to know what cosine 37 is, it would be 0.799, just 0.799 t. Okay, now we move on to sum of forces in the y direction. There is this frictional force here, mu of n, plus, I guess minus technically because we're going down twice to 2 of the weight, plus, and then there is an upward force from the tension, upward y component force from the tension of the string, which is t sine 37. And this would also equal 0. Now from here, mu is 0.5, so divide that by 2. Will give you 0.399. Minus 2Fg, for which we do not quite know yet, plus t sine 37. And can you see this? Okay. Sine 37 would equal 0.602 t. If you combine that with that, you get 1.001 t is equal to 2 Fg. Okay, and then finally we're gonna move on to the torque. Oh, you need the diagram again. Sum of all torques is basically sum of all the r cross f's in this diagram. So I'm going to actually place my point where I'm gonna start right here, where the star is. And this force right here, the distance is 0, so we don't have to include it. Likewise, for this force, the distance from the center is also 0, so don't need to include it. This one, force goes downwards, the distance goes this direction. So it's x cross, well, x times technically, Fg sine theta, but sine theta is at 90, so 1, basically you don't need it. Now the direction, if you do r cross f by the right-hand rule, would give you negative. So attach the negative. Plus, now this beam also has torque. So the torque would be, since this is a 4-meter long beam, the center of mass would be at the 2-meter mark. So the distance would be 2 meters times the force is Fg, except again, positive to positive x going downwards gives you negative torque. So I'm just going to do that, -1. Plus, there is one more right here. And we know the distance from here to here is 4, so 4 meters again. And then the force is T. This time there is an angle, it's sine 37. And if you go from here, this direction, by the right-hand rule, it will give you positive, so we're keeping the sign. Now, this sum of force torques will also equal 0. Okay, and here, you can plug this into here to give you negative, well, actually this might be better, negative x minus 2 of negative x plus 2 of Fg plus 4t sine 37 is equal to 0. Now we're going to turn Fg into t. So, actually I'm going to stop doing this. Negative x plus 2 Fg becomes 1.001 divided by 2, so 0.55. 0.5006, sorry, times t plus 4t sine 37 is equal to 0. Now, from here, you can actually simplify it further because you know what 4 sine 37 is. Can you see this? Yes. 4 sine 37 would give you that. So negative x plus 2, 0.5006t is going to equal negative 2.407t. We're going to divide both sides by this one. So what you would end up with then is negative x plus 2 is equal to negative 4.809. You get rid of the negatives, right? When you multiply both sides by -1. And then you subtract 2 on both sides to give you x is equal to approximately 2.809 meters. And that's how you solve question 19 of chapter 12. Thank you.